Good morning and welcome to the session on the future of networking and security. Got a few people coming in and getting comfortable here. Great to have you all here. And I guess before we get started, I'll just give you the standard disclaimer. You've probably seen this half a dozen times this week. I will say this is probably one of the more forward-looking sessions that you will see this week, so this disclaimer holds particularly true. But I am going to show you a lot of things that are real today. And what I hope you'll get out of this session is a strong sense of just how much networking is being transformed by the capabilities that NSX brings. So I've been around the networking world for a long time, and so I'm going to tell you a little story about my history of networking and how it relates to network virtualization. So I grew up in Australia, as you may have guessed from my accent, and in 1985 I left Australia and went to study at the University of Edinburgh in Scotland. And so in 1985 the internet existed, but it was not yet really well connected around the world. So the United Kingdom had its own internal network that did not generally connect to the internet. And Australia was in pretty much the same boat. So when I wanted to send email between my office in Edinburgh and my friends living back in Australia, I would send an email and it would go through the internal network down to the University College London, where it would sit in a server that every 12 hours made a phone call to a server in Australia, and it would exchange all the emails that were queued up, send them over the phone line, and then hang up. And then 12 hours later, it would do it again. So it took 12 hours minimum to get a return email conversation going between me and one of my friends back in Australia. So that was the state of networking when I entered the industry in 1985. So I'm not quite as much of an industry veteran as Pat Gelsinger, because Pat, I think, was designing the 486 chip when I was going off to Edinburgh. Fast forward another 10 years, and I moved into the networking industry, and I was working at a place called Bell Communications Research, part of the famous Bell system, and there was a serious conversation going on about what networking was really going to look like in the future. And I don't know if you remember the term information superhighway, but that was kind of what everybody was talking about in 1994. And the thing that's amazing to think about when we look back was that there were actually competing architectures for what the network of the future would look like. One was based on the phone network. The idea was you take the phone network and you would enhance it and add some more capabilities until you ended up with a network that could do everything. And then another architecture was you'd take the cable network, where it was really optimized for video delivery, and you would add other capabilities. But there was this idea that the information superhighway might be 500 channels of cable. And that was like one vision of the future. And then the third vision, which was not held by that many people, was that this little thing called the internet would become the basis of all future communications. And that picture there is actually a picture of Gopher. And anybody remember Gopher, the older? Oh, quite a few people. Good. So Gopher was one of those things that existed pre-World Wide Web as a way to move information around the internet. And so we all know that the internet won. The reason I believe the internet won was because it was the most flexible, application agnostic architecture that you could possibly think of. The internet was not designed to do one thing, unlike the phone network or the video network. It was designed to just support applications generally. And so the designers of the internet didn't know about the World Wide Web. It didn't exist, hadn't been thought of. But the World Wide Web was built on top of the internet because the internet was so flexible. So the reason I'm telling you this story is because the history of networking is all about building flexible infrastructure that can accommodate unforeseen future applications. So just one more networking story and then I'll get into the meat. So in 1995 I went and joined Cisco Systems, the one that starts with a C, not the one that starts with an S that we heard from yesterday. And the mission I was given was figure out some way of bringing together the capabilities of layer 3 networking, which Cisco was famous for, and the capabilities of layer 2 networking, things like ATM. So I worked in a team of people, and out of this idea came the idea of MPLS. And I ended up working on a book with Yakov Rector on MPLS. You can see it there. Yakov is actually the true father of MPLS. And if I could give you one piece of career advice, it's a great idea to write a book with a famous person. It really helps your career a lot. So The funny thing about MPLS was that we didn't actually know what we were doing when we invented it. We had this idea that bringing L2 and L3 together would be powerful and would give us new capabilities, but we didn't know exactly what those capabilities would be. And ultimately, the thing that happened was about 5 years later, MPLS VPNs came along, and that became a multi-billion-dollar business for Cisco and for the telco industry because we completely changed the way people built VPNs from how they had built them back in the 80s. And so that was an amazingly good example of how building flexible networking capabilities enabled an application that we actually hadn't thought of at the time we were doing the original design. So why am I telling you these stories? Because this is the decision that you have to face today when you think about how to build networking for your environments. You can build a network that's optimized for the things that you do today, and that would be go and build a traditional network. You know, buy the hardware from your favorite hardware vendor, optimize for today's applications. That's one approach. However, I will argue it's a much better idea to build a flexible, programmable infrastructure that lets you accommodate the applications that are going to come tomorrow that you haven't yet thought of. So this is really what network virtualization is all about. It's giving you a way to build flexible, programmable networking so that not only can you be optimized for today's applications, but you can be able to accommodate the new things that are going to come down the road. The only thing that's really constant in our industry, having now been doing this for close to 30 years, is that new stuff happens all the time. New types of infrastructure come along. You know, we have today all the opportunities to run our own private infrastructure or to use a wide range of different public clouds. New application architectures come along. Last year, we were all talking about Docker. This year, we're all talking about Kubernetes. Next year, maybe we'll be talking about something else. Pivotal, of course, is another big part of all of that. You heard a great announcement today about the relationship that we're building with Pivotal and Kubernetes and Google. I'll say a little bit more about that later in the presentation. And then, you know, some other new shiny objects are going to come along. Everybody's telling me that Bitcoin or blockchain is incredibly important. I have no idea if that has anything to do with networking, but I want to make sure that I'm ready for that in the future. IoT, sensors, serverless computing, all of these things are going to have an impact. We need to be ready for all of these new things. We can't predict what they will be. So you have to build flexible infrastructure. So network virtualization is the technology that lets you adapt to change. And change is the one thing you can count on in this industry. So you would have probably seen a slide like this before. Pat had one in his keynote yesterday that was a version of this slide. We've actually been using this for a bit over a year. This is the breadth of things that you can do with NSX. And, you know, we've typically focused on NSX in vSphere environments. And, you know, that's been enormously successful. I thought Pat was very direct in his keynote yesterday. He said, if you're not running NSX today, you're behind. You know, I kind of like it when a man tells it the way it is. We obviously feel at this point NSX is becoming a mainstream capability that enterprises are adopting, you know, at a great rate. But NSX can do so much more, and what I want to talk about today is all the other things we can do beyond vSphere environments. This is always a bit of a challenging discussion in a VMworld audience because I'm sure most of you are very loyal vSphere customers, but we also know there are these other worlds out there. There's public clouds, there's the new container frameworks, there's other hypervisors, much as we hate to admit it, and then there's things like how do we deal with edge computing, how do we deal with the branch. These are all areas where NSX is now starting to have an impact. And you had to pay pretty close attention to all the announcements we made this week to figure out exactly how many different products we launched. But we did this week launch NSX-T 2.0. And with NSX-T 2.0, we're now bringing native support for networking for Kubernetes and support for NSX cloud services. And so we'll be talking more about those later today. So, you know, one of the things I loved about the demo this morning, did everybody go to the keynote this morning? Hands up if you saw the pizza demo. So the thing I really loved most about that demo, actually probably was like what a bozo the CEO was, but the thing I loved the second after that was the tension between IT and developers. And, I've sort of learned this firsthand is that, there's always this kind of conflict between the developers wanting one thing and IT wanting another. And so one of the things that we're really trying to do with NSX is make sure that we can provide networking infrastructure that meets the needs of both developers and IT. And so, this is kind of where the idea of DevOps-centric IT comes from, the idea that you can be an operator or a developer or a hybrid of the two, and that we can provide infrastructure to meet the needs of these different communities. This means the infrastructure has to be something you can provision on demand, something that a developer can invoke a familiar API and provision the infrastructure automatically, or an IT operator can provision infrastructure using either scripts or automation tooling or a UI, but do it all in a seamless and service-like way. So that's all the introduction. What I'm going to do in the remaining time we have is I'm going to give you a two-part talk about NSX-T, the version of NSX that we just launched, version 2.0, that is going to help deal with these modern, complex environments. I'll start by giving you kind of the insider's view. In case you don't know my background, I was part of Nicira. I joined the VMware as part of the Nicira acquisition. I was part of the R&D team for 5 years, and then just a few months ago, I moved into a field-facing role. So in the first part of my talk, I'm going to give you the insider's view of how NSX-T has been built to deliver all the capabilities that I've just been outlining. And then in the second half of the talk, or the third half, depending on how you're counting, we'll have the things you can actually do with NSX-T. So I want to give you a sense of why NSX-T looks the way it does and how it can achieve its goals, and then a really practical sense of what you can do in your job to leverage the capabilities of NSX-T. And while the title of my talk and my focus here is on NSX-T, I want to make clear that NSX itself is a product that gives you a lot of capabilities that are not dependent on whether it's T or V. Some of the things I'll talk about are very T specific, but I'll try to make a lot of general points that apply to NSX more broadly. Okay, so I know I met one person this morning already who's still really learning about NSX. How many people here have been to, say, at least 2 NSX sessions this week? All right. And how many people here have done a hands-on lab with NSX? All right, so if you didn't put your hand up for the hands-on lab, you should do that. How many people have NSX in their data centers today? Phenomenal. Okay, that's only the best response rate I've had. Now, it's nice to see the uptick. So for those of you who haven't had so much experience with NSX, just a really quick refresher on what NSX looks like as a product. It's made up of 3 planes. The management plane is the way that you interact with NSX. It's the place where you can launch API requests. It's also the place where the UI sits. So if a human or a piece of software interacts with NSX, it's through the management plane. Sitting under that, we have the control plane. The control plane is really the brain. It does all the calculation to figure out how to make networks happen correctly. And then the data plane is where we actually implement the networking and security functions. So a really simple way to think about what NSX is, if you wanted to sort of boil it down to one sentence, is it is a logically centralized control plane, a logically centralized control of distributed networking functions. So you can think of, you've got routing, switching, firewalling, load balancing, a whole lot of networking services. Those are implemented in a fully distributed way, but the way you control them is through a single centralized point of control, which gives you a central place for a UI and a central place for API requests to come in. And that centralization of control is one of the things that makes it so powerful, as we'll see going forward. So just looking at how NSX operates, when you want to create a virtual network, you're going to specify that through the management plane. This could be a set of API requests, or it could be things you configure in the UI. But you have this idea, I want to build a virtual network with a certain topology, a certain set of services, and so I pass that into the management plane. And the management plane accepts that request, it will acknowledge the request, and it will store the request in the form of desired state. So now you've said, this is what I want. The management plane says, I got it. I'm going to remember that, and now I'm going to make it happen. It passes that desired state on to the control plane. The control plane does a whole lot of calculations. It goes and looks at what's happening in the data plane. Where are these virtual machines that you want to interconnect? And then it generates some output. It says, I need to go and program some hypervisors or some containers or some clouds. I'm going to go and program them to instantiate the actual realized state that you need. So from the top you have, this is what I want, and at the bottom you have, this is what you get. It's an implementation of what you asked for. And those are all the components that make it happen. So what I'm going to talk about now is how we can make enhancements to those three planes, the management, the control, and the data plane, to achieve the goals of NSX. So I'm going to start with the control plane, because as I said, it's really the brains of the operation. It's really central to how NSX operates. So the control plane has to deal with really two fundamental problems. And these are, in fact, the fundamental problems of networking. That the only thing that's hard about networking is dealing with heterogeneity, the fact that networks are so diverse, and dealing with scale, the fact that you have to deal with millions or billions of endpoints. If it weren't for that, networking would be easy. The control plane has to deal with those issues. Heterogeneity in this environment, if you think about all the things we're doing with NSX, heterogeneity means it's not just vSphere hypervisors anymore. It's also other hypervisors, it's containers, it's clouds, it's branch offices. So we have a much more heterogeneous environment than we've had in the past with NSX. So the control plane has to somehow deal with that. It also has to deal with scale. We're going to be provisioning thousands, tens of thousands of containers. We have to be able to deploy networking services to all of them. So we need a very scalable control plane while still maintaining this logically centralized view. So scaling the control plane is something that we started working on back in the Nicira days, and we leveraged the idea of clustering so that you have a group of compute nodes that are each doing one part of the control plane job. They create the illusion of being a single centralized point of control, but they're actually spread out across multiple compute nodes. So we scale by applying more compute resources to the task, and then we use distributed systems techniques, which I'll show you an example of, to make that distributed system look like one centralized object. To deal with heterogeneity, we had this insight after working on this problem for a few years, that the control plane can actually be separated into a centralized part and a localized part. So the local control plane is the part that maps between an abstract view of what you're trying to do and a concrete view of what you actually need to do in a particular environment. So for example, say I want to provision a firewall rule. So I can say, I need a firewall rule to be applied to this endpoint. I can then pass that information down to the local control plane, and the local control plane can say, oh, well, on this endpoint, the mechanism for setting up a firewall rule involves me programming, say, the distributed virtual switch. So I can do the mapping between the abstract requirement for a firewall rule and the concrete programming of a particular set of forwarding instructions on a particular vSwitch. Conversely, if I wanted to do that on a container host, I would send the same abstract requirement down to the local control plane, but the local control plane would actually map that into a set of instructions for how you program the forwarding table on a container host. So we have this idea that now the central control plane is doing less work and it's less cluttered by the complexity of all this heterogeneity. So we've kind of divided the problem up. And then those local control planes, they run out on every single host. So it's extremely scalable. If we have, say, 1,000 hypervisors, then we have 1,000 places to run that local control plane. So we get enormous scalability and we make the heterogeneity problem much easier. Okay, so that's the way the control plane is changing as we go to NSX-T to give you the ability to be scalable and heterogeneous. Let's now talk about the management plane. To be honest, this is probably the part of the talk that I find the most exciting. It's probably a little bit esoteric for some people, but so just bear with me while I sort of go through this, because I think you'll see some really cool computer science here, and there'll be a few important takeaways. So the thing about this environment that we're working in now is that the management plane is under increased pressure. You would have seen a demo this morning if you were paying close attention where Kubernetes and NSX were working together very closely. I'm going to show you a demo in my session as well that shows that. But so in an environment like that, the primary way that a developer is interacting with NSX is through the API. You could have thousands of developers all pounding on the NSX API in parallel. So that's a lot of load being placed on the management plane, asking it to do things. So to make that work, you need a scalable API service. Now, the API service has to be scalable, it has to be highly available, you can't have it going down because if it's down, nobody can do their work. But it also has to provide persistence because when you make an API request, you get an acknowledgement back pretty quickly. Yes, I got your request, I'm going to respond to it. I cannot now forget that I accepted your API request because the node that just accepted it could crash. It can't be the case that we lose an API request. That those upper layers assume that if the API request was launched and got a success response, then it's going to happen. So we have to actually take that API request and store it somewhere persistently before we can come back and respond to the API request. So we need persistence and scale and heterogeneity and high availability. We implement this using a thing called a distributed log, and I'll show you what that means in a minute. And what you get is a scalable API service. So if you only care about this from an end user perspective, scalable API service is the thing you care about. I'm going to give you a little bit more of the insider's view because it's really interesting technology. So you've got the management plane, which takes requests from outside, and you've got the control plane, which consumes that desired state and turns it into reality. Sitting in between the management plane and the control plane is what I think of as the source of truth. This is all the API requests that you've ever received need to be stored there so the control plane can consume them. The management plane is made up of a number of compute nodes. We can add more compute nodes to make it more scalable. Similarly, the control plane, we can add more compute nodes to handle more compute function down there. But we need a scalable persistence layer in the middle to store the source of truth, the desired state. And this is where the distributed log comes in. So let me explain what a distributed log is. A distributed log is a type of data structure. Now, most people, when they hear log, they think error logs, log files. Those are examples of logs, but it's not really the definition of a log. A log is not just a place where you store error messages. A log is actually a data structure that has the property that you never go back and modify anything from the past. You just always add new things to the end. So it's an append-only data structure. It's a really efficient way to keep up with a lot of new data coming in because you always just keep on writing to the end of the log. So you can think of the log as a history of all the API requests that have ever come in. So if I ever want to know what's the set of things that I have successfully processed, you can say it's whatever's in the log. And you can read that log from start to finish and get a view of what your current state should be. It's an immutable history of what's happened. So how do we make a log that's really scalable? Well, the fundamental limitation on a log is how fast can I write something to disk? If I'm writing to disk, I'm limited by the speed of the disk. So to go faster, I need to write to multiple disks in parallel. So a distributed log is a log that is spread out across multiple disks. But how do you do that? What you do is when you want to write something to disk, you write it into several different disks in parallel. You can get higher throughput by writing one request onto one disk and a subsequent request onto a different disk, and you can get more availability by writing the same request in parallel to multiple disks. Let me just go into one more level of detail, and then we'll pop back up into the use case. So when an API request comes in to a management plane node, the management plane node goes to this thing called a sequencer and says, where is the tail of the log right now? The sequencer says, in this case, entry number 12. Go right to entry number 12. And the layout manager is another component that says, to write entry 12, you need to go to these disks. And so we go and write onto these two disks. At the exact same instant, another API request could come in to a different management plane node and go to the sequencer. The sequencer is guaranteed to give a different sequential number to this API request. So he says, go write to entry number 13. The layout manager says, well, entry 13 goes on these other two disks. And so now we can write that in parallel. So the only thing here that is really centralized is the sequencer and the layout manager. Those are doing very lightweight operations. But the process of writing to disk, which is the slow part, is now fully distributed. So in this example, I used 4 different disks so that I could write with both high availability and a high degree of parallelization. So that's probably a lot more detail than you needed, but it's a really clever piece of engineering and computer science to build a highly scalable API service. So if you just want to take one thing away from this, it's that this is a very scalable way to build a management plane so that we can move into these new environments. And again, I'll show you the value of that as we get into some of the use cases later in the presentation. The final piece I want to talk about in terms of the architecture is the data plane. So obviously the data plane of NSX is also now extremely heterogeneous. We have all these different kinds of things that we can do with NSX. We can manage workloads running on vSphere. We can manage workloads running in public clouds. We can do them in KVM. We can do them in containers. And we'll keep on adding more and more of these as time goes by. One of the things I want you to appreciate here is that because of the architecture that I'm describing to you, it's very easy for us to add new kinds of endpoint. So, today we support NSX Cloud on AWS. If you went to Guido Appenzeller's session yesterday, you would have seen a demo of doing the same thing on Azure. It's really easy for us to keep on adding new types of endpoint because we have an architecture that's built for this kind of flexible support of heterogeneity. So the one thing I want to just sort of tell you a little bit about before I go on to the use cases is this new edge appliance that we have for NSX-T. So I think most of you probably know about the NSX Edge as it exists on the earlier versions of NSX. We have a new version of the Edge for NSX-T, and it leverages a technology that I'm sure many of you have heard of called DPDK. How many people have heard of DPDK? Okay, so that's maybe 20% of the audience. So DPDK stands for Data Path Development Kit, and it is an incredibly successful piece of engineering and marketing from Intel that has enabled astonishing improvement in packet forwarding performance on x86. So this graph from Intel shows the rate of improvement over the last 5 years from 55 million packets per second up to 346 million packets per second through a single server. And if you multiply that out, these are minimum length packets. That is on the order of 180 gigabits of throughput through a single server. So a lot of people say, how do I handle traffic between the physical world and the virtual world with NSX? And so the new version of the NSX Edge will handle 180 gigabits, well, plus or minus, of throughput between the physical world and the virtual. So the way we're doing that is a new design for the Edge. Instead of doing one virtual machine for every tenant of a single edge, we have what we've called a multi-context appliance. So what this lets us do is have one very tight loop of code that's forwarding packets for all of the different virtual networks that are going through a single edge. And so by keeping it all in one tight loop that's aware of all the different contexts, we can basically run always out of cache. And that is one of the ways that you're able to leverage the capabilities of DPDK. The other thing is you can't afford to do a lot of memory accesses if you're going to do packet forwarding at this rate. So we use a thing called a flow cache, so that when a packet comes in that you've never seen before, you go and look up, how do I process that packet? And you can say, do a couple of memory lookups to figure out, is it L3 forwarding? Is it L2 forwarding? Does it need a firewall rule? You do all that complicated processing once, and then you take the result and you store it in a cache. So now the next time a packet comes in, you can just look it up in the cache, single memory access, and forward the packet. So these two things together, combined with DPDK, enable an amazing performance improvement in the performance of the NSX Edge. Okay, so gets me to roughly the halfway point of the presentation. What I've now shown you is how we built NSX-T. So that was kind of the insider's view. What I'm going to do for the second half of the presentation is talk to you about what you can do with NSX. This might be a good time just to liven things up. Does anybody want to ask a question about the first half of the talk? We've got a couple of microphones in the aisles, or if you yell, I can repeat the question to the audience. So anybody got a question they want to ask before I move on? Yeah, right there. Yeah, I'm glad you asked that question. So the question was, can we make this high-performance edge that I just described, can we make it multi-tenant? That's exactly what it is. When I said multi-context, multi-tenant is another word for that. So effectively, if you have 1,000 tenants using your NSX deployment, and their aggregate traffic requirements can be met by one high-performance edge appliance, you can run them all through that. So you don't need a VM per tenant. You run all their traffic through the appliance. The appliance has its own concept of tenancy so that we can leverage the capabilities of the high packet forwarding rate. Thanks for that question. Yeah, I'd love to get these things clarified before we forget them. Anything else people want to discuss before we move on? All right, I assume that means everything was completely clear, and if I ask you any questions about distributed logging, you can all explain it to me. All right, so moving on, I'm going to tell you about what you can do with all this great new capability. So I thought I'd start by talking about the developer cloud. This is an on-premises developer cloud. And just as a quick aside, I think one of the most important questions of 2017 is, do we say on-premises, or do we give up and say on-premise, or do we cheat and say on-prem? There's a whole grammar discussion that I'm happy to have at the end of the session. Okay, so this is a screenshot that I took a week ago from the developer cloud that we use in the networking and security business unit at VMware. There's a few interesting things to notice here. Probably the most interesting thing for many of you is the fact that there's a little OpenStack logo up in the top. So this is an OpenStack deployment running on top of NSX and vSphere that our developers use to build and test code for NSX. This is a classic use case of NSX. We've been doing this since the Nicira days of having our own cloud where the developers can interact directly with infrastructure, and even people who aren't really developers like me can also interact directly with infrastructure. So I just went in and I provisioned a few virtual machines, I provisioned a few virtual networks, I connected them up, I allocated some IP addresses. Now, I did it all using the GUI because I didn't really have time to go and write a lot of code to do it. But if you were a developer doing this on a daily basis, you could actually write a script to do this repeatably, or you could use a template to do it repeatably. And so this is the modern way that developers deal with infrastructure. And so let me just say a little bit more about that. So as I said, this is an OpenStack deployment. It has all of the standard OpenStack APIs available at the top, which means any developer who wants to work with OpenStack, and that's what we find a lot of customers want to do today if they want a private cloud to support developers, they want standard APIs so the developers can use standard tooling to interact with their developer environment. So it's all the standard OpenStack APIs, a bunch of standard services like LDAP, and then all the things in green are the VMware components that plug in underneath OpenStack. And so you've probably heard of VMware Integrated OpenStack. We just launched a new version. I think it's 4.0, got launched yesterday. So VIO is a completely standard OpenStack implementation. All the APIs are open source. And then underneath it is the enterprise class management and compute and networking and storage that you need to run a cloud. We have helped a lot of customers get out of a lot of trouble with OpenStack by coming in and giving them the enterprise class infrastructure that sits underneath those standard APIs. And the developers have no idea that it's not, open source all the way down, but the IT department knows because it works. And so it's been a very successful use of NSX and other components to deliver a developer cloud. So a developer cloud basically lets the developer use things like Heat or Terraform templates or things like Kubernetes, as we'll see in a few minutes, to interact directly with NSX without IT being in the critical path to provision everything they need to develop and test and deploy production code. At the same time, you can have your IT people, your DevOps, using other tools like Puppet or Chef to also interact with the same infrastructure, and there's sort of separation of concerns so that some parts can be provisioned by IT and other parts provisioned by the developer. So one of the things that I want you to understand here is this is one of the fundamental shifts in networking that's going on. You know, we think of networking, if you're a traditional networking person, you know, you have a picture in your head like the one I showed earlier in the presentation of like a big blue box with like plugs on it and a CLI. That's the old way of interacting with networking, is you type stuff into the CLI. This is the new way of interacting with networking. You interact through APIs using standard developer tools or through things like an OpenStack portal or other tools like VRA. There's all these different ways to interact with a network. It's not just about typing at the CLI anymore. And this lets you start to do this wonderful thing called infrastructure as code. And, you know, I started hearing this term a couple of years ago, and I really wondered what were people talking about. It's actually pretty simple. Once you can provision your infrastructure using APIs and templates and scripts, then you can start treating infrastructure the way you treat every other part of your development lifecycle. So you have your DevOps in this example using a template, which is just a text file to define what goes into a development environment. That is a text file. You can check it into your version control system. You can have a continuous integration server like Jenkins that's picking up the fact that something new just got checked in. It kicks off a bunch of tests. You can come back and iterate through that loop. When you're happy with it, you move it off into your testing environment. You get some feedback from that. You make some more changes. You keep on iterating around these loops, and eventually you move it into production. And so you can have this consistent, repeatable set of processes for managing infrastructure just the same way you would for application code. So I was so happy when somebody explained this to me, because it's like, what are people talking about when they say infrastructure as code? It's just, you don't think of infrastructure as boxes anymore. You think of infrastructure as things that you specify in files that you can treat like any other piece of code. And that gives you access to all this other tooling that's been built up around modern software development methodologies. Okay, so now I want to show you how we can do something in the container world. And, you know, I sort of suspect that we hear a lot about containers, but a lot of us don't really know what people are doing with them. I'm curious, how many people here have container development efforts going on in their enterprise? So that's maybe a third of the room. How many people here think it'll happen in their enterprise in the next, say, couple of years? Yeah, that's more like 2/3 of the room. So for the remaining third of you, check your email or something. Container networking, you know, one of the things that is really exciting for us at VMware is that, you know, we're kind of known as the company that does stuff with virtual machines, and people have started saying, oh, well, you know, containers, it's going to be the end of virtual machines. Containers are not the end of virtual machines. Containers are just a great new tool for developing applications, and they need all the same kind of capabilities that we've been delivering for a long time. So I'm going to show you that right now. Here's an example of a containerized application. And I'm just going to show you one of the problems with containers as relates to networking. So just like any other application, your containerized application is prone to getting hacked. If a container gets hacked, that container is sitting on a container host. That's a single operating system running something like Docker. If you can compromise the container host, you can then move across into another container on the same host. It's a classic example of east-west movement. One of the things that we've worked to eliminate in data centers with NSX. It's the same thing is true here. You can move east-west within a container host. You can now move into a different application. and now move off into getting, say, some sensitive data. So because containers on their own don't really provide strong isolation, you need security. You need microsegmentation. Just the same way people want microsegmentation today to isolate their VMs, you also need microsegmentation between your containers. There's a whole lot of other enterprise networking features that containers need. You need visibility. You need to be able to see, what's gone wrong when an application isn't working properly. How do I troubleshoot that? All the things that enterprise networking is doing today needs to be available for container environments. So what a lot of our customers have said is, I like what I get out of NSX. I want to be able to use it for my containerized apps. So this is how NSX provides networking services directly to containerized environments. Down the bottom here, we've got a Kubernetes environment, bunch of networking there, some firewalling, some routing, some switching. That's all of that networking capability is going to be provisioned by the NSX manager, just as if it was a set of virtual machines. As I said, we have a special data plane that's designed specifically for containerized environments. It uses a virtual switch that can be inserted into your Docker host. But to the NSX manager, it looks like business as usual. It's just a set of places where I need to go and deploy networking services. Sitting between the NSX manager and your developer environment is this thing called a container plugin. So the container plugin is the thing that understands how NSX works, and it understands how the container framework works. So for example, if you go and deploy an application with Kubernetes, Kubernetes exposes a set of APIs. The container plugin can talk to those APIs, it can see what's going on, and in response to things that are happening in the Kubernetes environment, it will then go and kick off the appropriate actions in NSX. So I'm going to show you a demo. And I want to give credit to my colleague Eve Fowser, who's sitting in the audience, who built this demo for me on very short notice last week. So what I'm going to show you in the course of about 2 minutes is how we can build a 3-tier application using Kubernetes and secure it and network it using NSX. So on the left here, you have kind of the view of the application as seen by the developer. From his perspective, it's really just a set of containers delivering components of the application. It's a 3-tier application, nothing that fancy. It's got a front end that delivers the UI. It's got a middle part that does all the actual computation, and it's got a back end that stores the data. The developer's going to go and deploy that using Kubernetes, and then NSX will come in and apply all the networking. And so the thing that's really cool about this demo is the IT group who own networking get to set the policy ahead of time. You can say, anytime somebody does a 3-tier app, there's a certain set of policies that should be applied. And then the developer can go and do all their coding and come up with all the functionality and all the things they want to do. And then the minute that they deploy their application, all of those policies that were set by IT will automatically get applied with zero interruption to the developer's workflow. So IT gets to do the right thing, deploy the policies they're supposed to deploy, and the developer gets a native experience of just using the tools that are what they wanted to use. So this demo goes pretty fast. I'll give you a quick talk through of what's happening, and it's a recorded demo, just so we're clear. I'm not the sort of risk-taking person who'll do live demos. So here's a Kubernetes installation. It's pretty standard at the beginning. We've got a few different Kubernetes namespaces, and here's the NSX CLI showing we've got a logical switch for each namespace. We're going to go and deploy the application using a YAML file. And the YAML file is just a text specification of exactly what the application is going to look like. It tells us how many containers to use. It's got a few tags in there about some of the NSX policies that should get applied. And at the very end, you'll see there's actually a name of where we're going to deploy the service onto a particular host. So we hit the one-line command from Kubernetes, and we've started to spin up the service, we got a new namespace called Yelp app. And if you go and look back at NSX, we've now automatically got a new logical switch corresponding to that namespace. And if we go and look at all the things that Kubernetes is doing, it's basically spinning up a whole lot of containers. If you want to understand Kubernetes in a really sort of simple way, it's just a great way of orchestrating your containerized app. And so what you can see here is we've got a three-tier app with a back end, a middle tier, and a front end. Each of those is getting spun up as a container. And then we've got the ingress, which is where we'll consume the application. Back to NSX, we can now see that we've got a bunch of ports on this logical switch corresponding to the different tiers of the application. And if we go and look at the security on this, we can see that we've got a security policy based around the application tier, which basically says if the tag on the Kubernetes installation said application tier, then we get a particular security policy. And that security policy has now been applied to invoke a particular firewall rule on the application tier. And if we just go and look at that application actually running, what you'll see is there's the front end. We can now vote for different restaurants, and every time we click on vote, it gets counted and stored in a database. So you can see that the front end is communicating to the database, and everything's working as it's supposed to. Now, I'm just going to show you a quick thing in NSX where we just go and make one little change to the security policy. And we're just going to change one firewall rule in NSX. We make that change. And now if we go back and look at the application, what that one change did was it just dropped the traffic between the application tier and the database. And so now the application's broken. So all I really wanted to show you there was that NSX was really controlling the networking for that application. So just before I move on, since that went pretty fast, let me just summarize what we saw. We saw a developer who had an application ready to deploy specified in a YAML file. The YAML file is just a description of what my containers are going to do, where I can find the images, and how they're going to get interconnected at the level that makes sense to the developer. There's a little bit of tagging in there that can be picked up by NSX to say, for example, this is the application tier. So when NSX sees that, it knows to apply a policy that was previously defined by the security team for how we protect the application tier of a three-tier app. As soon as we hit deploy in Kubernetes, NSX was automatically notified of what was going on, and it automatically went and instantiated all the networking and security to give you enterprise-grade networking for that application. And that included firewalling, and we saw how we could make a change to the firewall policy after the application was running, which in this case caused the application to break, but the point was to show you that firewalling was actually active in that environment. So a very powerful way that the developer can get the native experience that they expect, and the NSX or IT administrator can get all the control and policy that they need. Okay, so the final thing that I want to talk about before we move into Q&A is VMware Cloud Services. So I don't have time to give you a demo here, but you can actually go and demo this yourself, because you can go to cloud.vmware.com and start playing with these services. So I'm just going to give you a few quick bits of information about NSX Cloud Services. So given that most of you know something about NSX, the two things you need to know about NSX Cloud Services are, A, it's a service. So rather than taking a piece of software and installing it in your environment, you can go to the cloud, it's already installed, and you can start using it. We operate it, we do the patch management, we update it with new features from time to time. So all of that is very typical kind of SaaS experience. What it looks like technically is roughly this. So at the top part of this slide, we have workloads that are native workloads running on AWS. In the future, there'll also be workloads running on Azure. Those are running in the customer, your VPC. Those workloads have embedded in them an NSX agent. So we give you special Amazon machine images that include an NSX agent and Open vSwitch. And then with that capability, NSX is now able to come in and apply networking and security policies to those workloads. The gateway that sits in the cloud is basically providing sort of edge type of functions, but also providing a level of isolation between the NSX control plane and the workloads running in the customer VPC. And then sitting down there in the dotted yellow line is the SaaS components that we operate on your behalf, the NSX Manager, the NSX Controller, and a plugin that talks to the customer's cloud portal. And so it's a very similar function to the plugin that I showed you for Kubernetes. It's sitting there looking at what's going on in the cloud so that when a new virtual machine is provisioned, we can kick off the appropriate actions in NSX to apply the appropriate networking and security policies. So, given that I don't really have time to go into this in great detail, let me just say that what we're showing you here is the ability to have that same kind of native developer experience. The developer is just developing things in a cloud-native way on the cloud infrastructure of their choice, while the NSX administrator or the IT operator gets to set policy and determine how exactly networking security should be applied to those workloads. So I just want to say a few concluding things before we open it up for final Q&A. I assume that you came to this session because you wanted to know something about networking. What I hope you will take away is that networking does not have to be a matter of typing at the CLI anymore. And it also doesn't have to be something that's siloed away in a dedicated networking team. It's something that if you're a vSphere admin, you can start to get involved in networking. And in fact, one of the things we've seen as people start to deploy NSX is it actually helps them improve cooperation between different groups in the organization because of the fact that networking is no longer such an arcane thing that's only something you can do if you can touch the hardware. So I want you to start thinking differently about networking. If you're a networking person, you need to think of it as it's a set of software. I deploy the software wherever the application runs. That could be running in a cloud or another cloud or my private enterprise. It could be in a VM. It could be in a container. Networking is not about I put a box somewhere and I configure the box. I mean, you still have to do that, but only if you want to be in the business of running your own infrastructure. Increasingly, people are going to run their applications on other infrastructure. And we're going to give you the tools to deliver networking and security services wherever your applications run. If you adopt network virtualization, you are setting yourself up for the ability to adapt to unforeseen changes. I think if one thing is very clear in everything I've heard at VMworld this week is most of our customers are trying to adapt to a very rapidly changing world. If you want to adapt to a rapidly changing world, you need infrastructure that can adapt to unforeseen things. That is what network virtualization is. It will let you deploy applications that you haven't thought of yet on infrastructure that maybe doesn't even exist yet because it's so flexible and future-proof. And you have a chance to be extremely influential at your company because you can be an enabler of digital transformation. All the things that I've shown you here are all about how do we enable you to get applications or new capabilities to market faster. That's the core of what digital transformation is all about. And if you're able to deliver networking and security services in a more agile way, then you will be enabling your company to be more successful. So I think it's a very exciting time to be somebody in IT. So, obviously, I'm a big fan of NSX. I've been involved with it for a long time. Hopefully, I've given you some ideas here about how NSX can be the foundation for a very bright future in networking. So here's a few parting thoughts. You should definitely go and catch the keynote at 12:30, right after this session on transforming security. Tom Korn is an amazing speaker, and you'll learn some great things from that. You should do hands-on labs. You should go to other NSX sessions. With that, I will wrap it up. We've got about 5 minutes left to take some questions. I thank you very much for your time. Please come to the microphone if you have a question, and please remember to do your surveys, especially if you like the session. There we go. First question here.
The embedded agent you referred to in the images, is that the CNI?
The embedded agent in the images, it actually comes in two parts. It's not the CNI. It is a little piece of NSX code that runs in user space, and then there's the open vSwitch that provides the switching. So the combination of those two is what lets NSX control the networking security for that VM.
Thank you.
Go ahead.
It's a great presentation. I really appreciate that.
Thank you.
One thing is, so far we have been doing the management for the AWS and everything at the top level, doing the orchestration. Do we have any future training how we can actually integrate at the data path level where the packet is going using the VXLAN overlays or something like that, where you can tag the packet coming from on-prem and you can apply the policies on the cloud based on the tags itself?
So in general, what we're doing with our AWS strategy is we're saying any policy that you want to set in NSX, you can do it independent of where the workload is. VXLAN is just really the mechanism for tunneling the packets from one place to another, but there's not really anywhere inside VXLAN to put more policy information about the data. So we do, as you say, apply policies by saying, this is how I'm going to handle these packets as they come in and out of those endpoints.
Okay. Okay.
Can you provide some more color on the support model of NSX-T on the edge with DPDK?
So the support model for NSX-T, basically the NSX-T, its edge is an appliance. It is part of the standard set of NSX software. So if you have an NSX license, every component of NSX is covered by that support. So we will do validation on specific hardware. There'll be HCL things just like with any other situation where our code runs on particular high performance hardware, but the support is through us.
Okay, thank you.
It's so interesting. Pat started his presentation today with a question about support, and somebody next to me said, "Why are we asking questions about support?" But it's super important, right? So thank you for asking that. Yeah.
I'm curious if you can speak to whether or not there's any plans to merge the two current NSX streams with T and V, and what that path may look like going into the future? Yeah,
so I'm happy to take that. So it's really probably a broader question about the ongoing relationship between T and V. So today, V is the product that will meet the needs of most customers running in their vSphere environments. T is the product that will meet these much more heterogeneous, complex environments. Over time, T is going to become more and more and more feature-rich to the point where it will be an equally good choice for vSphere environments as NSX-V is today. So over time, we expect more and more customers to adopt NSX-T, whatever their environment is. There will probably never be a day when the two products actually merge, but there will be a day when there's one product that everybody's needs will be met with, and that'll be some future version of NSX-T.
So from your perspective, that product would be T, yeah?
Yeah.
Okay. And I guess that it's kind of unfair, but just a second follow-up to that, to piggyback off that. From a features perspective, is there any sort of a matrix that you can refer someone to that shows the key differences from a support perspective of what T has today and what V has today from a base NSX outlook? I'm
pretty sure that matrix exists, and I'm happy to help you find it if it's not easy to find.
It's been a challenge for the last few weeks.
Yeah, we just launched NSX-T yesterday, the latest version, so I would expect that collateral to be available this week. But please follow up with me, and I'll help you get it.
Okay, thank you.
Yeah.
What are the capabilities around tapping the traffic for packet capture, diagnostics, forensics, things like that? Yeah,
so packet capture is basically a built-in feature of NSX. It's basically we can always do effectively like span a port just like you would on a physical switch. Yeah. Okay. So, last question, I think, and then I'm going to have to get out of here.
Sure. Thanks. So we are at the brink of building out a brand new data center. We are primarily a VMware shop.
Yep.
So given that, what is your recommendation? Should we get married with T or just stick with V since we know it so well? Like, what is your professional recommendation there?
So I'm hesitant to give a recommendation to you in front of everybody because people might misinterpret it, but I would say from what you've just said, you probably sound like a V customer. So our general recommendation is if you want to do an OpenStack developer cloud, if you want to do multi-cloud, if you want to do containers, T is your choice. Other circumstances, which sounds like what you're describing, V is the choice for that sort of typical mainstream customer.
Okay. I'd love to spend some more time to get reasoning behind your...
Sure, absolutely.
But,
you're welcome to talk to me. I would also say there'll be people at the NSX booth on the show floor who can give you a great level of insight on that as well.
Perfect. Thank you so much.
Yeah. All right. Okay, very, very last question.
Yes. The NSX-T with DPDK that you talked about also applicable to NSX-V with DPDK, or is it more confined to...
As of today, it's an NSX-T feature only. In principle, I don't see a reason why it couldn't make it, but today it's a T thing only.
Okay, thank
Yeah.
you.
Thanks.